Welcome, everybody, to the 2026 Northeast Extension Fruit Consortium's Winter Webinar Series. Today, we have the dating game updates on Lepidopteran mating disruption with Dr. Tracy Leskey. Tracy holds a PhD degree in entomology from the University of Massachusetts Amherst, a master's degree in ecology from the Pennsylvania State University, and a bachelor's degree from Wilson College in Pennsylvania. She's been employed with the USDA ARS in Kearneysville as a research entomologist and laboratory director. Her research has focused on development of behaviorally based management tools for invasive and native pests of fruit crops. She has published over 200 peer-reviewed journal articles, 2 patents, and over 40 other publications, including book chapters and proceeding articles. She has served as liaison to the House Agricultural Appropriations Committee, providing numerous updates on the pest status of and research progress on the invasive brown marmorated stink bug. She has supervised numerous postdocs and graduate students. Dr. Leskey has been interviewed by the New York Times, the Washington Post, and NPR, and appeared live on Fox News and C-SPAN, and has done several stories with National Geographic. As the lead project director, she has secured over $22 million in extramural funding. She is a subject editor for environmental entomology, a fellow of the Entomological Society, and past president of the ESA Eastern Branch. So we are exceptionally excited to have Tracy joining us today. Thank you for taking the time to come and speak with us today, Tracy.
Thanks, Liz, and for the invite, and thank you to all for joining. So good morning, everybody, or I guess good afternoon now. So yes, we're going to talk about the dating game, and in particular, we're going to talk about codling moth and oriental fruit moth mating disruption in what we call non-compliant blocks, as well as mating disruption efficacy for peachtree and lesser peachtree borer. And this project is something that is part of our USDA NIFA Specialty Crop Research Initiative grant, which is Cultivating Tomorrow's Orchards, where we as a team with most of the tree fruit entomologists, along with economists and sociologists, are working to try to develop improved IPM tactics for some of these persistent pests that our growers are dealing with. So we'll start with codling moth and oriental fruit moth. Both can be direct fruit feeding pests, and they have multiple generations per year. The damage that becomes economic, of course, in particular, is when larvae are burrowing in the fruit and feeding, leaving behind unsaleable products. And for many growers, this can lead to rejections, particularly for processing if live larvae are found. With codling moth and oriental fruit moth, they have multiple generations per year, which also complicates management of these pests. In terms of the typical management that we think about for both of these pests, and in particular codling moth, because that's usually the more difficult pest to manage, we have Biofix degree models, which can be used that are typically start when we see sustained captures and traps in the spring. This is usually like 5 to 7 moths in the trap. And then there's usually ovicide or egg killing sprays recommended. There are also egg hatch degree models for codling moth that target the larvae. And in terms of the materials that are recommended, there are a number of LEP-specific materials, the diamides, things like Altacor. There are premixes of these diamides with pyrethroids. There is Delegate or spinetoram, a which is a neonic, and there are biopesticides like Sidex, the codling moth virus. There's also a threshold in the literature for these guys, where in traps, 5 codling moth or 10 OFM per week could indicate the need to put a spray on. These actually do not, well, anyway, these are like best guesses thresholds. So we found out by doing some research with some of our retired colleagues. So this is what's really out there right now. And then of course, the other is mating disruption. And mating disruption, if you think about for any female moth, with codling moth and oriental fruit moth, the female releases a pheromone. This plume follows behind based on the wind direction, and males typically orient upwind to find her. In the case of mating disruption, what we do is to basically flood the zone. We put out lots of uh, point sources of pheromone that then can either do one of two things. One way they can disrupt the males is through what is referred to as competitive attraction, which is essentially false trail falling, where the male is confused because there are so many different trails, he can no longer find the female within the context of an orchard. There's also what is referred to as non-competitive attraction, which is based on basically, again, flooding the zone. But in this case, the receptors on the male antennae, which is the way he detects the pheromone, become overloaded. It's sensory overload. So it's a habituation response. And again, they can't find the females. So with mating disruption, with mating disruption, one of the things that I got very interested in during the start of the pandemic, I went right down a rabbit hole, was the accepted guidelines for mating disruption for codling moth and oriental fruit moth. And where did these recommendations come from? And there are three in particular. One is that orchards should be isolated from non-mating disruption plots or wild hosts to avoid dispersal of mated females coming in. The second is orchard borders, because they're vulnerable to depletion of the pheromone concentrations that are needed for disruption, means that we can't use long and skinny plots. They have to be more square in shape. And then finally, they should be on flat topography, small trees, again, square in shape, and at least 5 acres in size. So this is a problem in the East in particular. And so I kind of also wanted to know, where did these recommendations come from? So tracking back from this 2007 review article back to this book from 1999, and eventually got to this book from 1990. Um, the data that are used to make these recommendations that we're still following came from Switzerland in the 1980s. And so I was kind of like, well, that's a long time ago. Our orchard systems have changed, the products have changed. Maybe we should think about um, wondering if we could make this strategy work. And obviously, there's a big reason for this. Many grower farms in the eastern US have trouble meeting all of these criteria. We know this. And so this took us down the rabbit hole of what I call non-compliant mating disruption, which is basically trying to disrupt codling moth and oriental fruit moth in blocks that are not the right size, shape, or topography. And so the key question we were trying to address is, can we develop a strategy to make mating disruption work for codling moth and oriental fruit moth in these non-compliant blocks? Fortunately, here at the Appalachian Fruit Research Station, we have a lot of experimental blocks at our disposal, which are all definitely non-compliant. And so in 2022, we went out with a very simple design where we wanted to try mating disruption in non-compliant apple bucks. So in April, we deployed the mating disruption ties, the isomate twin tubes for codling moth and oriental fruit moth, and 4 experimental blocks. We also had 4 blocks that received grower standard programs and 4 with no treatment at all. Again, all non-compliant. Then we harvested fruit in September when during the season to look for both codling moth and oriental fruit moth damage. And we looked at 10 apples per tree, 20 trees per block, so 200 per block. So this was the first year. So no spray control. You can see we had a good amount of codling moth injury at harvest. Mating disruption, it was reduced by half. And then the grower standard program, you can see, was significantly lower injury. Oriental fruit moth, same story, though there was no difference between the no spray control and the mating disruption only. We had some good pressure out there. But what it meant was that probably mating disruption only was not going to hold up in these non-compliant blocks. So this led to us thinking about a different design. And so, let me show you these. And this is where we kind of got to this different design. In 2022, these are our trap captures. And if you overlay those existing thresholds that I mentioned at the beginning of the talk for codling moth, which is 5 moths per trap per week, you can see that in these blocks, and especially in the no spray control, we were definitely exceeding that threshold. For oriental fruit moth, which is 10 moths per trap after the first brood, again, it looks like we were exceeding threshold. So we thought, well, maybe if we combine mating disruption with these thresholds, we could manage these pests a little better. But because we still had trap captures in the mating disruption only blocks, but not to the threshold that was established previously, we thought maybe we needed a more conservative threshold for these non-compliant blocks. So, come on, there we go. So this led us to ask the question, can we integrate threshold-based sprays with non-compliant mating disruption for effective management of codling moth and oriental fruit moth in association with thresholds? So first, we asked, would the existing extension threshold of 5 codling moth and 10 OFM integrate well with these non-compliant mating disruption blocks? Or should we halve these and have a more conservative threshold of 2 codling moth and 5 OFM? So we started in 2023 and we did this for 2 years in 23 and 24. We again went out in April, deployed the mating disruption ties, again, the twin tubes, and we had 2 monitoring traps per block. All of the blocks were non-compliant. Because OFM mating disruption ties kind of run out in terms of what the company recommends, we did put new ties out in July. And then in September, again, we did fruit harvest. And so the treatments we had were the standard insecticide sprays, mating disruption only, like we had the previous year, and then these 2 mating disruption blocks with thresholds. First, the extension recommended threshold, and then our more experimental conservative threshold. And so I'll take you through the results. And so in 2023, come on, there we go. In 2023, these are the trap captures in our monitoring traps. For codling moth, we use the 10x lures that are recommended for mating disruption. And codling moth pressure was high in the mating disruption only blocks. And as a reminder, this block, the only thing that it received was a pedal spray for everything because we had, curculio and everything else. But you can see the threshold. Here's the 5 and here's the 2. And then for OFM, we used, in this case, we didn't use that first year, we used 5 OFM lures to kind of create our own super lure for these mating disruption blocks. And so you can see this is the extension recommended and this is the experimental. The threshold sprays were never triggered by OFM, but they were triggered by codling moth. So in terms of the number of applications that were triggered, so the grower standard, we had 1 petal fall spray and 8 cover sprays. It was a super long season that year. And then for the thresholds, you can see we had 1 petal fall spray and 1 to 2 threshold triggered sprays for these blocks. That year, when we look at damage in these blocks, it became very encouraging to us because for codling moth injury here's the grower standard, mating disruption only. And then when we triggered sprays based on those thresholds, you can see we had the same amount of injury compared with the grower standard. So it looked pretty good. Oriental fruit moth, it was much the same. We had a little bit higher threshold damage in the threshold with the lower threshold sprays, but overall it was pretty good. And then this is just the number of larvae that we pulled from those fruit at harvest. So overall, it looked pretty encouraging. In 2024, codling moth was pretty high in some of our experimental blocks. And this year, we also deployed 2 OFM traps per block because we wanted to try our 5X lures with the Tracy OFM male-female lure. And so from petal fall onwards, OFM traps of both types did not hit threshold. And you can see that here. So really what was driving our sprays in these non-compliant blocks, again, was the codling moth. So damage at harvest and sprays. So here are the sprays. Again, grower standard, we had 1 petal fall spray and 7 cover sprays. for the lower, more conservative threshold, we had 1 petal fall spray and 2 to 6 threshold triggered sprays. And then the higher threshold, we just had the 1 petal fall spray. We actually didn't trigger anything else, which was kind of interesting. So what did we get in terms of damage? So we did have higher codling moth pressure that year, but overall, it wasn't too bad. We had the more conservative threshold worked well, and statistically, the amount of injury was similar to that of the grower standard program. And so overall, it was looking pretty good, and we were reducing the amount of injury by about 50% compared with mating disruption alone. So we found 3 total larvae that last this in 2024. So we said, we didn't analyze this. So this is all on our experimental farm. So the next thing that kind of came along was this opportunity to work with a grower that we have a good relationship in Smithsburg, Maryland, about 35 minutes away. This particular grower had some serious codling moth and OFM problems to the point where he does like 10 farmers markets in DC, and he was having people return the fruit because he had such high larval presence in his apples. So in this case, what we decided to do was what I would call the kitchen sink experiment, where he has never used mating disruption before. He was just using mainly conventional insecticides. So, and he also does alternate row middle sprays, and he continued to do that through this program. But in his grower standard insecticide spray program, he overlaid this with the codling moth, oriental fruit moth twin tubes. And he doubled the concentration at the border because, the potential for dispersal and decline of the concentrations at the edges. And then and he also actually used some virus as well. So all of that in here. And then in the other plot, he used mating disruption plus that lower experimental threshold of 2 codling moth or 5 OFM per trap. And the lures he used were the 10X codling moth lure and that OFM male-female combo. And so we decided to start this work in 24 just to see if it could improve his overall outlook. So these are the results from 2024. This is the number of ARM applications, first of all. So in his grower standard, you can see it would be about 9 sprays, full sprays, but he was doing alternate row metals versus the threshold where we reduced the number of sprays by about a quarter. And these are his trap captures over the season. Here's that threshold. You can see he had some pretty significant codling moth pressure, and he had a bump of oriental fruit moth pressure in the beginning. But what was exciting for him was that at harvest, this is the percent damage, it was almost non-existent compared with the previous year where he was having rejected fruit. So with the threshold treated blocks with mating disruption, he was able to reduce his sprays by about 25%, but he had almost 100% clean fruit, 99.2% or whatever clean fruit. And then in his standard program, he had 99.75. So again, when it was all codling moth, we found no oriental fruit moth damage at harvest. So this looked pretty good for him. And then the other thing, so we continued with that in 2025. And so come on, there we go. In 2025, these are the results again for the entire season. In fact, we were in 2025, after his second year of doing mating disruption across these blocks, and in using the threshold, he was able to reduce his sprays almost by half, so about 45%. And you can see in the second year, he had codling moth below threshold for nearly all the season, and he never hit any thresholds for OFM. And again, at harvest, it was 99.75% clean fruit. And what we did find were a couple of damaged fruit from codling moth. Again, no oriental fruit moth. So this was super exciting and it looks really good. And he calls himself now the poster child for mating disruption. And especially in these non-compliant blocks. So key messages. So mating disruption appears like it can work in these non-compliant orchard blocks, but we need that backup of the insecticide applications, and particularly using a conservative experimental threshold. I think the lower one is more important because it gives that level of comfort, but it appears to work well. It manages the pests really well, but also reduces the amount of chemical being applied against these pests. And the nice thing about these threshold-based sprays is that you can really target problem blocks as needed, whereas other blocks that you're not seeing the issues, you can continue on. So we're really enthusiastic about this. Our next steps are really to develop the economics behind this with our economist on our SCRI project. Okay, we're going to move on to peach tree and lesser peach tree borer. If anybody's growing peaches or cherries, these wood boring pests can be quite a problem, or apricots or plums. So any prunus really. Um, so these pests are both wood-boring insects. Peach tree borer has one generation per year. Lesser peach tree borer can have two. The larvae in both of these species are the damaging stage, feeding on the cambium and can kill and girdle trees. Although most people I talk to think that peach tree borer is obviously the bigger issue. You find them feeding around the base of trees and in the roots, and then in the canopy on scaffold limbs and wound sites is where you'll typically find lesser peach tree borer. And you can see the frass and the gummosis and the pupal cases left behind when these guys pupate to the adult stage. Okay, so oh, I just remembered, Glenn, one thing that about back to your question, those were averages across all the blocks. There were some blocks that hit threshold more often. So anyway, I just want to throw that into. Okay. Peach tree borer attractants. So before we could get into mating disruption, just like we were talking about with codling moth and oriental fruit moth, we wanted to go back and look at the attractants available for monitoring these guys. There is a threshold that's out there that I could find, and it was that if peak captures anytime during the season are greater than 10 males per trap per week, that could indicate that you have a damaging population. The males, by the way, are the the more of the wasp looking individual, and the females of peach tree borer are these large purpley black with a large orange band across its abdomen. Okay, so peach tree borer, these are, when we decided to do this trial, we tried to find every commercially available lure and evaluate it season long. And we did this actually over 2 years. And there's a century clearwing moth that's recommended, a peach tree borer from lure from Tracy, Alpha Sense, and then we also threw in an unbaited control. We did these in peach orchards. They were deployed season long and re-randomized every 2 weeks. We had 3 plots with 3 replicates per plot, and all were conducted in commercial orchards. And these went from the 4th of May until the 18th of October in 2023. But again, we did these in 24 as well, but I'll just show you 23. So these are the results from the lure trials. And interestingly, Century's clearwing moth lure was far superior to the others. We got far more peach tree borers in that um, traps were baited with that lure. And in these commercial plots, we never did hit the so-called threshold for these insects, but we did find active populations in all orchards. Lesser peach tree borer, this particular insect, again, you typically find it in the scaffold limbs and in wound sites up in the canopy. Its pheromone, which is EZ313 ODDA, is the sort of the exact opposite isomer of the peach tree borer pheromone. And then there are a couple of, this ZE may be a synergist. And so the pheromone of peach tree borer is actually an inhibitor for lesser peach tree borer. So basically what it means is that their pheromones are slightly different to ensure they do not mate with the wrong species. So again, we put we wanted to do a monitoring trial with these guys. There is a recommendation for monitoring. There is no threshold, but what we could find when we were seeing what recommendations were out there, there was a recommendation to implement control if you find 2 larvae or empty pupal cases per tree. So first, we wanted to look at the lures that were out there. We had the Century lesser peachtree borer, the Tracy lesser peachtree borer. Alpha Sense has a lure as well. These are the weeks after, or by the way, when they require or they recommend they be changed. And again, we did these in commercial plots, 3 replicates per plot, and did these season long in 23 and 24. And again, I'm just going to show you 23 because the results were identical. So in this case, again, Century's peachtree or lesser peachtree borer lure was far superior to Alpha Sense and Tracy. But again, no threshold. But this told us what we could use then when we start thinking about implementing mating disruption for these guys. And so forever and ever, Lorsban or chlorpyrifos was always considered the gold standard, a trunk drench application. But several years ago, EPA canceled its registration, but it was overturned. But Corteva, who was really the main producer of that compound, stopped producing it. And there are some smaller companies that still produce it, but in some states it's not permitted. Some states it still is. And it's just sort of, what most people would say is as a treatment for these pests, it's really on life support. So most states are recommending mating disruption for both of these pests, although some states will recommend Asana or esenvalerate or cormoran, which is an acetamiprid and novaluron combination, or Ryman as a trunk or scaffold spray. But what we were interested in was really learning more about mating disruption itself. So mating disruption for peachtree and lesser peachtree borer, there are some data out there that have demonstrated that it can work on smaller acreages. This was done by Daniel Frank when he was at WVU on smaller acreages of like 1.5 acres. There are dual dispensers of the 2 pheromone components for peachtree and lesser peachtree borer. The recommended rates are 150 ties per acre for low to moderate populations and 250 for higher populations with additional ties on the border. And in this case, placed at chest height at the center of the tree. And the idea is to put it out pretty early to prevent female mating. So we started this work in our new peach plots here on the farm. We have 6 plots that we can do this work in. These are the cultivars that we currently have: Loring, Flaming Fury, Crimson Rocket, and John Boy. And we went ahead, and because these plots are small and there isn't a lot of information out there, we went with the high rate of 250 ties per acre. And then our control was a Lorsban trunk drench to have sort of the best, out there in terms of what should kill everything in the tree. We monitored each plot with a lesser peach tree and peachtree borer baited trap for each. And we assessed peachtree borer density season long with the 10 adults per trap threshold, as well as fall scouting, looking for just to see if we could find any pupal cases. And for lesser peachtree borer, we wanted to also look for the pupal exuvia or pupal cases through fall scouting. So this is the results for peachtree. These are the results for peachtree borer. In the Lorsban control block, which is in blue, and the peachtree borer, which is in orange, with the threshold, we caught no individuals in our traps in the mating disruption blocks. We went out and scouted, and we found very few pupal exuvia either in the Lorsban treated plots or in the mating disruption plots. So overall, I think it looks pretty good, and we're pretty pleased with it. Again, these are young peach trees, so we really do want to protect them. They're just starting to come into their fruiting years now. Moving on to lesser peachtree borer, again, we didn't capture anybody in the mating disruption block except this little blip right at the beginning, and there is no existing threshold. We did go out and scout for people exuvia, but we did not find anybody. So it looked pretty encouraging for these insects as well. So overall, we're going to continue this work, but overall, I think it's a really good replacement for Lorsban, and even in smaller acreage, I think it's working well. So tentative conclusions so far from this mating disruption work for peachtree and lesser peachtree borer. I think it's working well. It's a reliable replacement for Lorsban, and we're going to repeat it in 2026. Um, Something that I hope we get to talk about a little bit at the end is this idea of grower hacks, especially for these insects, because we hear from growers that they're still getting good disruption, even if they decrease the number of ties per acre or even the frequency. I have some growers that talk about maybe doing it every other year or every 3 years. And that can be okay because these pheromone lures or the pheromone compounds themselves are pretty large, so they're heavy. And with the ties, there is carryover into the next year. We know that. And so what we want to do next is work with our economists to look at both mating disruption as well as Lorsban trunk treatments, both from the standpoint of the materials, but also the labor behind this, because Lorsban treatments are pretty intense, from a labor standpoint, as is putting up mating disruption ties. And then just how we can incorporate some of the hacks that are out there to make this more economical, but yet um, something that's efficacious on a farm. So these are our next steps with this project. And I think that's my last slide. Yeah. So I want to thank the USDA NIFA Specialty Crop Research Initiative grant. By the way, so for folks in the Northeast, Jaime Pinheiro and Monique Rivera are both on this project. And then also our in-house funding sources and my lab group, who that was us having camo day. So we're going to continue this work, but I'm really enthusiastic about these sorts of studies, because I think for growers trying to make things work, we have tools out there so they don't feel as restricted, and using some of these products and have the confidence that they're going to work. So I think I'll stop there and turn it back to you, Liz.
Well, thank you, Tracy. I appreciate you taking the time to come and join us and share your research. I know a lot of our folks have been really interested in how to successfully implement mating disruption in their blocks here. So this has been great information for us.
Yeah, I'm happy to talk about it. We'll have some more data as we move forward, but it's something I think if we can make it more flexible for people who do not necessarily meet all those size, shape constraints, I think it can work. But I don't think it's a standalone. I think you need something else in the
Mhm.
background going on. So, yeah.